Assalamualaikum warahmatullahi wabarakatuh. So, hello everyone. In this chance, Team 1 are going to explain about our group project, and it is about a closed organ pipe. So, let's just get started. So, first thing, I want to introduce myself. I'm Jasmine Salsabila. So, as you guys know, the most important thing about a musical instrument is the sound, right? You can tell what musical instrument being played by the unique sound they play. Also, you guys can make a musical instrument out of things you saw in your daily life, such as a bamboo. You can make a flute out of a bamboo, also a drum out of a gallon. And the last thing is a bottle flute. You can make a bottle flute out of a glass filled with water. So the waves moving through each other with their disturbances adding as they go by. And if two waves having the same amplitude and wavelength, they can alternate between their constructive and destructive interference. And the resultant will be like a wave standing in a place, and it is called a standing wave. The example of a standing wave is a wave in a bottle of syrup, and a guitar string, and also organ pipes. So, musical instruments use the principle of organ pipes, and organ pipes is a sound producing instrument, and the pipe will resonate at a certain tone when there is a stream of air being blown at the right pressure. So, there is a one type of organ pipes, and it is called closed organ pipe. It is when a column of air with one end closed and then the other end is being opened. Example of a closed organ pipe is a bottle flute. It is when you bring a glass, and if you fill it with water and you blow it, and it will produce a sound.
Hello, my name is Hirzani Azzahra, and I'll explain a bit about our experiments, and I'll start with the definition of the sound. Sound is defined as vibrations that travel through the air or another medium as an audible mechanical wave. It is called vibrating body, and the vibrating body causes a medium like water, air around it to vibrate, thus producing sound. There are solids and liquids that are good conductors of the sound, while air is a poor conductor of the sound. Generally, the speed of the sound increases with the density of the medium. Because a sound is the result of the vibrates that propagate, a sound has frequency and also an amplitude, where the frequency will determine the level of a sound, and amplitude will determine the strength and weakness of the sound. Each sound source will produce the different frequency from one another. We have an organ pipe. An organ pipe is a sound producing element of the pipe organ that resonates at a specific pitch when pressurized air is driven through it. The organ pipe, which has one end is open and another end is closed, it's called closed organ pipe. And the example of closed organ pipe is the bottle and also the whistle. And then if both ends is open, it's called open organ pipe. And the example of open organ pipe is the flutes. There are the examples of organ pipe. I think that's all. Thank you.
I'm Aisyah Rizki Aulia, and I'll be representing the third part, or the data part. A closed organ pipe uses 4 equals to V per 4L as a standard equation. So using n equals to 1 as the basic tone, render it useless to use 3 or 5 as n, because it's respectively second and third high note. In closed organ pipe, you understand that the second and the third organ note is respectively 3 times of the tones before, so 3 times basic tones equals with second high note, and the third and 3 times of the equals with third high note. Note that the formula doesn't change throughout the experiment. I'll read you the data we already collect. As you can see, the note C have a frequency based on the formula of 523.2 Hz, while the column height based on the formula is 16.3 cm. and the frequency by application of 439 Hz. Continuing with the same order, it's note D with 586.6 Hz, 14.6 cm, and 451 Hz. Note E with 659.2 Hz, 13 cm, 645 Hz. Note F with 698.4 Hz, 12.2 cm, and 697 Hz. Point G with 784 Hz, 10.9 cm, and 738 Hz. Note A with 880 Hz, 9.7 cm, 867 Hz. Note B with 987.8 Hz, 8.6 cm, and 953 Hz. And the last note, C crest with 1046.6 Hz, 8.1 cm, and 992 Hz.
Hello everyone, I am Nabila Hartina, and this part I want to explain you more about this topic. Based on the result obtained from the data above, it can be seen that the frequency value, both seen from the formula and using the application, is influenced by the column height. Increasing the column height makes the frequency value smaller, both the frequency value based on the formula and the application. With each increasing note, the frequency value will also increase. From the data above, the frequency value based on the formula and application produce different values, even though they are in the same note. However, if the frequency value based on the formula increase, the frequency value based on the application will also increase. In general, this shows that the frequency will still increase as the column height decreases, even though the frequency values are generated in different way. Thank you.
So, in this part, we're going to answer some questions based on our experiments. And before we continue, let me introduce myself first. Yeah, my name is Aji Wibowo. Hello. I'm going to answer those questions based on our results of our experiments, and I'm going to answer it one by one. So let's get going. Let's answer our first questions. First question is there a change on the water before and after hitting it with the metal rods? If there is change on the water forms, what will it change into? The answer is no, there will be no change on the water before and after we hitting it with the metal rods. But if you ask us if there's a change on the note based on the amount of water inside the bottles, the answer is yes, there will be a change on the notes based on the amount of water inside the bottles. When the amount of water inside the bottle is higher, the note will get higher too. Same as the opposite, if the note is lower, it means that the amount of water is lowered. So yeah. Moving on to our next questions. Does the water height inside the bottles have an effect on how the note sounds, and why is this happening? The answer is yes. There is an effect on the height of water inside the bottles on how the note sounded. When the column height is higher, the note will get lowered, while the opposite is we can get it while we reduce the column heights. If you asking why is this happening, it is because the mechanical properties of the pipes is that determines the pitch that the pipe will produce, and also the pipe height will also determine the pitch that the resonance of the at the specific frequencies. So yeah, there will be a effects on the heights of the waters inside the bottles on the sounds of the notes. And for the last questions, after doing the experiment, how does the note forms? Of course, this is based on our own observations on our experiments. So the answer is, we all know that resonance frequencies is always depends on the speed of the sounds, which is p, and the length of the tubes, l. A disturbance will move down, will traverse down the tubes at the speed of the sounds, and it will bounce off at the close ends. If we have the right length of tubes, length of the tubes, the reflected sounds will arrive or bounce back at exactly half cycle later, and it interferes constructively with the continuing sound produced. Inside the tube, the standing wave that form inside the tubes will always have a maximum air displacement or an antinote at its close ends, and what's it called? No displacement, no disturbance, or a note at its open ends. So yeah, that's all of the answer of those three questions. I think that's all I can say, and I will moving on to Kivlan.
Well, hello there. This is Kivlan. You already know me. But before I ended this video, I want to explain about the frequency, note, and the organ pipe, also the experiment as a whole. Probably you have seen our friend's video, Miss Fitri, where they hit the bottle and produce the sound accordingly. We also have that scene in this video, but the margin of error is just too high. And I can assure you that by any means, all the sounds that we produce from these bottles won't, and I repeat, won't achieve the note or the frequency needed to form the note, the diatonic note. It is just because your journal, which you reference the experiment from, is flawed. The journal doesn't explain the means that we need to form such an experiment, and the little data that we have cannot form such a detailed report of forming the note. It is just a mere illusion of auditory by our ears and mind. The journal on which the questions of this experiment comes from doesn't explain the necessary needs to form such notes, the length of water, the type of bottle or container in any type, or how we should hit the bottle, on which all of it render important in this experiment. You can watch the right experiment here. I will provide you the link down below. The problem with this experiment are we don't have the correct tools. The organ pipe is in minimum state of 1 meter long, and we don't have that too, with consistent diameter and girth, and the journal does not talk about anything measuring the correctness of the note with frequency, not the note, not with a frequency and not with wavelengths, nothing. In which, in this experiment, a few of my friends' experiments and the journal you base these experiments on failed to give. So you're now asking, why do it works in others' video when they can sing with the homemade organ pipes? As I explained earlier, it is a mere auditory illusion. The reason why we don't give a singing video or a music video because it's that it won't be right on this occasion to do so. From this video, the BBC provide about the McGurl effect I based my argument on. When a visual overrides your understanding of audio illusions, it means that audio can override audio illusions too. It means that what you are hearing is not what you're hearing at all. You are hearing what you want to hear. Ears are not to be trusted. You can watch the full video here if you want, if you are interested in that. Audio overrides another audio. That's why when you overshadow the bottle's audio with humans or tools that are pitch perfect or trained to be pitch perfect, you hear that it's close to be correct when in reality it is far from doing so. Now, I don't want to undermine what my friends have given to you. They are nice and very talented people, but I have a different stance on this issue. Why must we lie to ourselves to achieve something that is close to mere impossibility? It cannot work. It won't work. I am sorry to disappoint you like this, but the truth is always the truth. We cannot change it. Thank you. That is probably all from me. Wassalamu alaikum warahmatullahi wabarakatuh.